shark alpha was around 9–10 feet in length. About 2 months later, the tag showed this shark had been chased down where it appeared to have been devoured by something, showing it was inside the stomach of something.
Great white sharks have ruled the oceans for millions of years.
Of white sharks from being a coastal species, at least in the Northeast Pacific, to being an open ocean species.
Feared as near unstoppable predators. But what happens when one of these apex hunters suddenly disappears without a trace? Imagine tracking a massive shark for months, only to see its final moments recorded as it's swallowed whole and dragged into crushing depths. What kind of creature could overpower a great white shark, an animal long considered the ocean's top predator? The answers don't just surprise, they expose a chilling truth about what really lurks beneath the waves. The vanishing of shark alpha. In 2003, off the coast of Western Australia, a team of marine biologists set out on what seemed like a routine mission to study the behaviour of the great white shark.
In 2003, I was involved with satellite tagging program to better understand the movement patterns of great white sharks.
Among their subjects was a healthy 9-foot female the team named Shark Alpha. She moved exactly as expected, patrolling the coastline and following familiar hunting routes. For months, her movements gave researchers a clean, reliable look into the life of an apex predator. To track her, scientists attached a satellite tag that recorded depth.
Everything that shark is doing, we'll be able to ride the back of the shark for a couple of days and see the behavior of that animal.
Temperature and light levels. The plan was simple. After several months, the tag would detach, float to the surface, and transmit its data to satellites. But things didn't go as planned. Not long after deployment, the tag washed ashore, far earlier than expected, and just miles from where Shark Alpha had first been tracked. Early detachment wasn't impossible, so researchers initially assumed a malfunction. But when they downloaded the data, what they found was anything but routine. Shark Alpha had been swimming in cold water, around 46 degrees Fahrenheit, when suddenly the tag recorded a sharp spike to 78 degrees. This wasn't gradual. It was instant. The only place in the ocean where that kind of temperature shift happens so suddenly is inside another animal. At that moment, the conclusion became unavoidable. Shark Alpha hadn't simply disappeared. She had been eaten whole. The data grew even more disturbing. At the exact moment of the temperature spike, the tag recorded a rapid descent. Not a slow drift, but a forceful plunge, nearly 2,000 feet into the dark ocean below. Something powerful had taken her and dragged her straight down into the depths. The scientists discovered that their results presented crucial findings that they needed to investigate further.
Tracking this layer day and night means that this is very important even for the highest predators in the ocean.
A predator that stands at the top of the food chain had been slayed by an unknown creature that possessed superior size and strength and attacked with sudden speed. The narrative continued to develop beyond that point. The underwater tag operated for 8 days while it collected data about its internal temperature, which remained constant. The predator had kept Shark Alpha inside its body for an extended period because the system took time to process its entire body. The tag left the system after it had been inside the system for a specific period of time. The device ascended to the ocean surface while it brought back an exact timeline of all events that had transpired. The information that had been spread throughout the area turned into facts. The actual information served as digital proof, which documented the transformation of the predator into the hunted. The incident generated multiple theories after the news about it became widespread. The unidentified sea creatures became one of the new theories that emerged. The prehistoric megalodon theory resurfaced, which proposed that the giant shark lived on in the unexplored regions of the ocean. The public became fascinated with the concept that a creature obtained the power to defeat a great white shark. Scientists maintained their focus on evidence-based research. The tracking device recorded 3 specific types of data, which included temperature, depth, and time measurements. The information presented itself as complete evidence, which showed all events that had taken place. The remaining question required an answer to determine which animal possessed these abilities. The researchers discovered through their data analysis that different predator species demonstrate distinct behavior patterns. The ocean surface needs further exploration to discover its hidden monsters, which exist outside of human knowledge. The real news: the shark alpha disappearance created both an enigma and a danger signal. The top predator position does not provide any creature with actual immunity from being attacked by others. The secrets hidden in Shark Alpha's tag led to the importance of understanding shark tracking technology, a key tool that revealed this unprecedented event. How shark tracking works. Satellite tagging has transformed how scientists study the great white shark. These aren't simple trackers.
Of white sharks from being a coastal species. It wasn't until the advent of some of the technology that we use, like satellite tags, that literally changed our minds overnight.
They record depth, temperature, movement, and behavior in real time while attached to the shark's dorsal fin. Researchers carefully approach from a boat and secure the tag, which stays on for months, collecting continuous data. Once its time is up, the tag detaches, floats to the surface, and transmits everything to satellites. This process gives scientists a rare window into the hidden lives of these elusive predators, revealing patterns and behaviors once impossible to observe. The tags become revolutionary because their functions extend beyond location tracking. The system measures depth through water pressure detection, while it records water temperature to show how sharks move through their daily activities. The system uses light sensors to identify daylight hours, which improves the accuracy of location tracking. The shark behavior analysis provides scientists with comprehensive details about the animal's active periods, which include its hunting and resting times, as well as its reactions to environmental changes. For biologists, it functions as a real-time record from an animal that they cannot observe during extended periods. The Shark Alpha tag operated according to its design by monitoring normal shark movements for almost 4 months along the southern Australian coastline. She exhibited her regular swimming pattern, which included hunting behavior for seals and small fish, as a top predator through the water. The data confirmed existing research about great white shark behavior and their natural habitats until the tag unexpectedly disconnected and the data became available. The situation presented itself as normal operations, while the research team anticipated valuable scientific discoveries from their upcoming research work. The technology includes built-in unexpected elements that produce the actual situation that occurred when Shark Alpha's tracking device data was retrieved and analyzed. The data showed her traveled paths, but it unexpectedly revealed the violent manner in which the shark died. The sharp, immediate temperature increase, combined with the extraordinary drop in depth, could only mean one thing: the shark had been swallowed. The tag functioned as more than a device to track his physical movements because it documented his entire underwater experience, which turned into a terrifying situation. Shark research has become dependent on these tracking devices because they show researchers shark behaviors that they cannot observe through direct methods. Great whites can dive thousands of feet, and much of their world remains cloaked in darkness. The tags enable scientists to study these concealed areas through remote observation, which shows how predators interact with their environments. The ocean would have hidden Shark Alpha's disappearance story from history if this technology had not existed. To comprehend how this event fits into the world of sharks, we need to examine the biology of cannibalism in great whites, a brutal survival strategy hidden beneath the waves. Cannibalism among great whites. At first glance, the idea of sharks preying on their own kind feels unnatural. Great white sharks are often seen as solitary rulers of the ocean, with no real threats once they reach full size. But the ocean doesn't work that way. It's a place defined by competition, where even apex predators are not exempt. Cannibalism among sharks is not rare. It's part of their biology, shaped by millions of years of survival. Some species display this behavior before they're even born. Sand tiger shark embryos, for example, develop teeth inside the womb and consume their siblings in a process known as intrauterine cannibalism. Only the strongest survive. While great whites don't follow this exact pattern, it reveals something important. This behavior is deeply rooted in shark evolution. In the wild, great white shark interactions can turn violent. In places like South Africa and Guadalupe Island, scientists have documented large individuals attacking smaller or injured sharks. These aren't emotional conflicts or territorial grudges. They're opportunistic encounters in a harsh ecosystem. A weaker shark becomes food, nothing more. When researchers analyzed Shark Alpha's tag data, the signs pointed strongly toward this kind of behavior.
Corey has identified 5 main contenders that have the size, strength, and attitude to be an alpha shark.
The recorded temperature spike, rising suddenly to 78 degrees, matched the internal conditions of a great white's digestive system. Unlike most fish, great whites can regulate heat in certain parts of their bodies. Through a specialized network of blood vessels, they maintain warmer stomach temperatures, allowing them to digest large prey efficiently. That detail mattered. The tag wasn't just inside a predator, it was inside something with the exact biological traits of a great white. The depth data reinforced this. After the attack, the tag showed a rapid descent of nearly 2,000 feet. This aligns with the known behavior of large great whites after feeding. They often dive into colder, darker waters, possibly to digest in isolation or avoid competition while vulnerable. The pattern wasn't random, it was consistent. Taken together, the evidence painted a clear picture. Shark Alpha had been swallowed whole by a much larger member of her own species. To consume a 9-foot shark, the predator would have to be enormous, at least 16 feet long and weighing over 4,000 pounds. Some scientists believe even larger individuals exist, possibly reaching 20 feet.
20-foot, 2.5-ton great white shark in the waters of Hawaii.
These giants are rarely seen, likely spending much of their time in deeper waters beyond regular observation. That raises a more unsettling thought. How many of these massive great whites are out there, moving through the ocean unseen? This reality forces a shift in perspective. Great whites are not untouchable rulers. Within their own species, a hierarchy exists, one driven by size, strength, and survival. The strongest dominate, and sometimes they feed on their own. With cannibalism among great whites providing such a convincing explanation, the mystery deepens when comparing this behavior to the hunting patterns of other powerful ocean predators. The orca suspect theory. While the idea of a massive great white devouring Shark Alpha was unsettling, it wasn't the only theory researchers explored. Another powerful predator quickly became a prime suspect, the orca. Often called slayer whales, orcas are actually the largest members of the dolphin family, known for intelligence, coordination, and lethal efficiency. In several regions, including South Africa, California, and Australia, orcas have been documented hunting great white sharks. Their strategy is precise and calculated. Working in pods, they force sharks upward, then flip them upside down, triggering tonic immobility, a paralysis-like state. Once the shark is helpless, they deliver fatal bites, often targeting the liver, a nutrient-rich organ packed with energy. This behavior became impossible to ignore in 2017 when multiple great white carcasses washed ashore off South Africa. The pattern was disturbing. Their livers were gone, sometimes along with the heart, yet the rest of the body remained mostly intact. The wounds appeared clean and deliberate, not torn apart like a typical shark attack. Researchers linked these events to 2 male orcas, port and starboard, believed to have developed a specialized hunting method. The effect on the ocean was just as striking. Great whites in the area began to vanish after orca sightings, abandoning hunting grounds almost overnight. In some cases, they stayed away for months. Scientists describe this as an ecology of fear, a rare situation where even apex predators retreat. Orcas weren't just hunters, they were reshaping behavior across the ecosystem. The evidence suggested that orcas had slayed Shark Alpha. The team possessed 3 essential traits that enabled them to fulfill their objectives. The theory created a perfect match with the story, which explained the intense competition between 2 opposing groups. The data presented a different narrative. Temperature provided the first evidence. Shark Alpha's tag recorded an internal reading of about 78 degrees Fahrenheit. Orcas maintain their body temperature at levels that exceed this temperature because they belong to a warm-blooded mammal species. The numbers didn't match. The tag wasn't inside an orca. The next stage revealed their eating preferences. Orcas demonstrate selective feeding behavior because they only take specific organs from their prey while leaving the rest of the body behind. The data showed that shark alpha had been entirely consumed by the predator, which kept its tag inside for several days. This kind of complete ingestion is not how orcas feed. The final contradiction was behavior. The predator executed a deep dive, which reached a depth of almost 2,000 feet following the attack. The mammals required for air breathing absolutely need to breathe air at frequent intervals. Orcas need to come up for air at regular intervals. The movement of the creature resembled the behavior of a large fish instead of a marine mammal. The sharks in the area remained calm while they continued their normal activities. The entire evidence suggests that the group of orcas did not attack the target through their organized strategies. The evidence that once supported the orca theory now showed that the theory had been completely dismantled. The next challenge was to sift through these legends and fears, giants of the deep that could explain the vanishing of shark alpha. Mythical and prehistoric theories. The mysterious disappearance of shark alpha sparked the imagination of armchair ocean enthusiasts and scientists alike. When conventional predators like orcas were ruled out, the public naturally gravitated toward more sensational explanations. Chief among these were two chilling candidates: the colossal squid and the megalodon, a prehistoric shark often portrayed as the ultimate sea monster. Colossal squid, relatives of the giant squid, are enormous deep-sea creatures that can grow over 45 feet long. Their massive tentacles are lined with sharp hooks, perfect for snaring prey in the crushing darkness of deep underwater canyons like the Bremer Canyon near where shark alpha vanished. It is easy to imagine a scenario where shark alpha strayed too close to this deep drop-off, was suddenly seized by a tentacled monster, and dragged into the inky abyss in a terrifying struggle. However, this squid theory hits an immediate roadblock: temperature. As cold-blooded invertebrates, colossal squids have internal temperatures that match the frigid, deep ocean water around them, usually just a few degrees above freezing. They cannot generate the internal body heat recorded by shark alpha's tag, a steady 78 degrees Fahrenheit. This crucial detail proved the squid hypothesis to be a dead end, no matter how haunting the imagery it conjured. Turning to prehistoric possibilities, the megalodon once seized the spotlight. This giant shark, believed to grow as large as 60 feet, was a whale predator that ruled the seas millions of years ago. For decades, tales and theories have suggested that this ancient beast never truly went extinct, instead retreating into the deepest, darkest reaches of the ocean. With jaws wide enough to swallow a small car, a surviving megalodon would be the perfect explanation for the violent end of shark alpha. The megalodon theory seemingly checked many boxes: a predator large enough to consume a 9-foot great white whale, powerful enough to perform an enormous vertical dive, and warm-blooded like its modern great white relatives, possibly matching the 78-degree internal temperature found in the tag's data. To many, it was an exciting narrative that captured imagination and filled in the gaps left by modern science. Yet, scientists remain unanimous in rejecting the megalodon idea, citing a lack of any concrete evidence. No modern megalodon teeth, no fresh giant bite marks on whale bones, and no undeniable sightings exist. The presence of such a colossal predator would leave enormous footprints on marine ecosystems, changes that no one has observed. It remains a captivating but unproven fantasy, a tempting explanation that does not withstand rigorous scientific scrutiny. This conclusion cast a new shadow over the ocean's hierarchy, where the greatest threat to a great white might not be some unknown monster, but a monstrous version of its own kind. The terrifying conclusion. After ruling out orcas, colossal squids, and ancient legends, the evidence led to a far more unsettling answer: a much larger great white shark. Data from shark alpha's tag matched the internal temperature of a great white's stomach, followed by a rapid descent into the ocean's twilight zone. This wasn't a struggle, it was the aftermath of a successful slay. The ocean's apex predator had been eaten by its own kind. To consume a 9-foot shark whole the attacker had to be enormous, at least 16 feet long and weighing over 4,000 pounds. Some estimates push it closer to 20 feet. Unlike the great whites often seen near the surface, this giant likely lived in deeper waters like Bremer Canyon, where massive predators move unseen. The attack occurred with quickness because an ambush from below used size and force to deliver an unexpected strike. The tag showed little resistance, suggesting Shark Alpha was taken instantly. The system operated through an integrated tracking device, which it digested along with itself minutes after it consumed its food. The predator descended to almost 2,000 feet after it finished its meal. The behavior shows that great white sharks tend to leave their feeding areas for colder underwater spaces, which provide them with safe places to digest their food. The tag data showed this specific pattern, which provided observers with access to an uncommon hidden behavior that turned out to be terrifying. The research results demonstrate that great white sharks do not maintain control of ocean waters. The species displays a violent social system that establishes rank among its members. Sharks that weigh more than others establish power over their group, which leads to incidents where they consume smaller sharks. The question about the existence of giant creatures in nature remains unanswered. Shark Alpha's fate reveals a harsh truth about the ocean. Shark Alpha's story reshapes our understanding of the ocean's true apex predators. Instead of mythical beasts, the evidence points to a ruthless hierarchy where the greatest threat often comes from something bigger, faster, and just as deadly. If you found this glimpse into the deep as fascinating as we did, don't forget to like and subscribe for more explorations into the unknown, and tap the next video on your screen to keep diving deeper into what the ocean is still hiding.